Hello everyone, this is Revathi, Assistant Professor in Information Technology from SNS College of Engineering. In this lecture video, we are going to see about IPv4 addressing. IPv4 supports three different addressing modes. There are unicast addressing mode, broadcast addressing mode, and multicast addressing mode. First, we can see about unicast addressing. The destination address field contains 32 bit of IP addresses of the destination host. Here, the diagram will represent the unicast addressing. Unicast means one sender can send the message to one receiver. And the message will be passed from one direction to another direction. The opposite is not possible. Then the second one is broadcast addressing. The destination address field contains a special broadcast addresses, that is 255.255.255.255. That means one sender can send the message to multiple receiver. This diagram will represent broadcast addressing. Here the server will receive the messages. Server A, server B, and server C will receive the messages from one client. That is called broadcast addressing. Then third one is multicast addressing. In this addressing, the destination address contains a special address which starts with 224.x.x.x and can be entertained by more than one host. Here the diagram will represent the multicast addressing. That means a client will send the messages to the switches or hub that will forward to the multiple servers. Here the server B will send the message to switch, then server A and server C will receive the messages which is coming from the server B. That is called multicast addressing. Then next we will see about IP address format. It is divided into 5 different categories called classes. That means class A, class B, class C, class D, and finally class E. This diagram will represent the address format of IPv4 addressing. The class A is 1 byte for net ID and another 3 bytes allocated for the host ID. Then for class B, net ID will be allocated for 2 bytes, then another 2 bytes for host ID. Then for class C, first 3 bytes will be for net ID and last one for host ID. Then class D, multicast addresses. Then class E, reserved for the future purposes. Then each address has a network prefix and host number. This will represent the network address. That means it will start from 192.168. Then the host address. Next 2 bytes will represent the host address, that is 2.33. It contains 4 octets or fields separated by a dot, and each field is 8-bit in size. Each field number should be in the range of 0 to 255. Then this table will represent the differentiation of the classes from A to E. A, B, C, D, E will ranges from 1 to 255. Then the default subnet mask will be represented by 255.0.0.0. Then for the class E experimental. Then next one is addressing in V4. Here the offsets will be represented by bits that will start from 0 and end with 24 bits. Then class A, 0 byte for network, then another 3 bytes allocated for the host. Then class B, first 2 bytes for the network ID and another 2 bytes for host ID. Then for class C, first 3 bytes allocated for the net id, then another last byte will allocated for the host id. Then for class d will represented for multicast address, then class e reserved for the future use. Thank you.